All right, welcome everybody. We are going to start on chapter 7 today. So here's our chapter 7 notes. Chapter 7 is called Comparing Two Means or Medians. And section 7.1, our first section of the chapter, is called Tests for a Difference Between Two Means. So for this section, we're going to focus on the means, and we'll get to the medians later. All right. So last chapter, I'm going to go ahead and read this paragraph right here. We got a great deal of practice finding the means of different data sets. And for our project, that was part of the comparison we did for the conclusion. We compared the two means against each other and saw which one was higher. This section, we're going to dig deeper into the comparison between the two means, okay? So let's look at a data set here for our first example. So it says, did the Baltimore Ravens have a greater ability to score at home during the 2017 NFL regular season? Here are their points scored for games at home and on the road, okay? So you have them there. We could just find the means of each of these and compare them, which we actually are going to do, but we're going to get back into that whole null versus alternative hypothesis testing that we were doing last semester. So the first thing we want to do is state the appropriate null and alternative hypothesis. Now, remember on these ones, we always said that the null hypothesis is the one where whatever our comparison is like things are the same or no change. It's kind of the big idea for the null hypothesis. So they said here, did the Ravens have a greater ability to score at home? So my null hypothesis is always going to be not that. It's going to be that these things are kind of the same. So I'm going to say for my null hypothesis here, the Ravens had the same ability to win at home as on the road or as away. So, yeah, let's say as away. How about that? If you said on the road, that's fine as well. They mean the same thing, okay? So then for the alternative hypothesis here, so I'll do that in red as well. All right. So the alternative hypothesis would be kind of based on the question up here. It said, do they have a greater ability to win at home? So I'm going to use that fact there. And so I'm going to say for my alternative hypothesis, the Ravens had a greater ability to win at home versus away. So this one, I'm not saying that they're the same. I'm saying one is better. How do I know which one to say is better? Usually they're going to kind of tell you in the question here. So they said, the question is, did they have a greater ability to score at home? So that's what we're going to be trying to test here with the alternative hypothesis, okay? Okay, next question. Explain what it would mean if the null hypothesis were true. Okay, so if the null hypothesis were true, I mean, like it says in the null hypothesis, the Ravens had the same ability to win at home as away. But to kind of expand on that, because even if we saw a difference here, this is only 8 games at home and 8 games away. So it's not a ton of games. And so what would it mean if the null hypothesis were true is that if the Ravens could play millions of games at home and away. So if we expanded this, so it was more than 8 games, like it says millions of games, if we just kept doing this to some huge sample size, the mean number of points scored would be the same home versus away. All right, so we're kind of taking that out. If we expanded this, even if we're seeing that these two means are not the same when they played 8 games at home and 8 games away, if the null hypothesis is true, which again, we don't know that right now, where we're going to check it and see if we think the null hypothesis is true or the alternative hypothesis is true. But if the null hypothesis were true, we're saying that if we played millions of games, they would be about the same. All right. Okay, so let's now calculate the mean for each distribution and the difference in means home minus away, okay? So then how we're gonna do this is we're just gonna add up, I'm gonna actually grab my pen here. Okay, great. Oops. All right, so we're gonna find the average here. So remember average, we call it with like the X bar. And so a lot of times what they'll do with this is they'll use a subscript. So I'll do one that's like X bar is the mean, and then I'll put a little subscript H right there, meaning I'm just talking about the mean of the home games. All right. And then I'll do the X bar for the away games. All right. So we'll figure this out. So we're gonna have to add up all the numbers. So 27 plus, and I'm just gonna go dot, dot, dot here. And then I'm just gonna go plus 24. So I'm adding up all the numbers from that home list. And then I know that there are 8 numbers in total. All right, so let me grab my calculator. We'll add all those up. All right, so we got 23 plus, 27 plus 23 plus 44 plus 23 plus 40 plus 24 plus 9 plus 24. So that gives me 214 over 8. And that's going to be 26.75. All right, so then for this one, same idea. We're going to add up 27 plus, and then we'll go dot, dot, dot. And we're going to add up all those away game totals all the way to 20 and divide that by 8. So 27 plus 38 plus 23 plus 20 plus 16 plus 30 plus 7 plus 20. And I got 181 there. We're going to divide that by 8 as well. So that gives me 22.625. All right. And then we'll go ahead and find the difference here. All right. So I'm kind of out of space. Let me just use a different color here. So if I do the mean of the home games minus the mean of the away games, I'm just going to subtract those two values. So 26.75 minus 22.625. And that gives me 4.125. So that's a very important number there. I'm going to go ahead and box that up because we will be using that later. I need to know what's the difference in means. Okay, so or actually, let's go down a little bit here. I'm going to go back to typing to use this. Okay. So what are 2 explanations for the evidence in the preceding problem? So what we see here is that very clearly their average for the home games is higher than their average for the away games. And it's more by 4.125. That's the difference. So it's saying on average at home, they score 4.125 more points per game at home than they do away. So what are 2 possible explanations for that? All right. Well, one explanation is going to kind of explain if the null hypothesis is still true, how do we explain that difference, right? And then the other one is going to be, well, if the alternative hypothesis is true, how do we explain that difference? Let's go through both of those. It'll be very similar to what we did in previous units, but here's what I'm going to say for the null hypothesis. All right. So I'm going to say that the Ravens' ability to score at home is the same as away, but they scored more at home in this season because of random chance. So that's just saying that generally, like we kind of set up here on explain what would mean if the null hypothesis is true. My explanation would be, yeah, we did see a difference in the average number of points scored in the home games versus the away games, but this was only 8 games at home and 8 games away. So that could have been just random chance. They just had some bad away games or they had some really good home games. And if they did this like a million times, though, that difference in average would get a lot smaller and maybe even go to 0. Okay, so that's the alternative. That's the explanation if the null hypothesis is true. If the alternative hypothesis is true, which once again I don't know yet, the explanation would be that of course, so the greater average at home proves that or doesn't prove, I'm going to say actually shows that the Ravens have a greater ability to score when at home. So that one's kind of saying, yes, we cannot ignore that difference right there. Clearly, they're doing better at home. So this is justification for us saying that they score more when they are at home. Okay. So two kind of conflicting explanations there. Like I said, we don't know which explanation right now is correct, and we're going to continue this process to see which one is correct. Okay. Okay, so next thing we're going to do, which we kind of did this before as well, explain how to use note cards to simulate the difference, home minus away, and mean number of points scored, assuming the Ravens had the same ability to score in each context. Okay, great. So here is what we're going to do for that one. All right. So since we go back up here, they played 16 games here. They played 8 home and 8 away. So using 16 note cards, so that's for all the games. Label each card with one of the 16 values for points scored in the 16 games. So I would take all of these numbers from their home and away games. I would have 16 cards, and I would write each one of those numbers on one of the cards. So 16 cards with all those 16 different points on them. Okay. And then after that, I would shuffle and deal into a pile of 8 cards and a pile of 8 cards to represent home games, and another pile of 8 to represent away games. We're kind of simulating the season, assuming they scored all the same points in those 16 games, but now we're randomizing which ones are home games and which ones are away games. So this is just us kind of doing an experiment here. Then what we would do is calculate and record the difference, and we would do home minus away, just like we did before, in mean points scored. So we need to calculate the mean again, and then subtract them just like we did before. So repeat this process many times. Okay. So that's how we would do that simulation there. Okay. Now, good news, we don't have to do that simulation. They're going to do the simulation for us. All right. So you can see here the dot plot shows the results of the 100 simulated season as described in part A. Use the dot plot to estimate the p-value. Okay, so for the p-value, we are looking for how many dots, and we can write this over here on the left column, okay, if we need to, or how many dots at or above our observed mean difference, okay? So we can see that this chart is referring to the simulated difference in mean number of points scored. Okay. So it's like they simulated the season, and then for each simulated season, they did what we did up here, and they calculated the mean of the home games and the mean of the away games, and they subtracted them. Okay. So our observed mean difference was right here, 4.125. And so that's why I said this is such a key number right here, this 4.12. Oops, I'm trying to highlight that, excuse me. This 4.125, okay, right there. Can I get a highlighter here? There's the highlighter. Okay, so that's the key there, the 4.125. We're going to carry that forward down here. So for this one, we're looking for all the points that are greater than or equal to 4.125. We're going to count them up, okay? And so 4.125 is, let's see, this is probably 5 right there. So I'm going to say this first one looks like 4.1, so I'm going to cut it off right here. Oh, I tried. Can we do a little zoom in? There we go. Okay, so I think it would be like right here and then over. All these dots are at or above 4.125, okay? So let's count those up. So it's 2 in the first one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, so my p-value then is going to be 24, okay? Because there's 24 dots. So it's the number of dots that are at or above that 4.125, okay? So our p-value there is 24, all right? Okay, so what conclusion should we make based on the p-value? So remember, we learned that 5%, that 5 dots out of 100 is kind of our magic number. And so remember, if p-value, okay, if it's less than or equal to 5, then there is evidence for the alternative, okay? Because that means it's a very rare event to happen randomly, so it's probably that they were actually better, okay? So in this case, obviously our p-value is greater than 5. And so I would say here, something like, because it is fairly likely, and we say p-value equals 24, or you could say 0.24, or I'm going to say 24% since it's 24 dots out of the total 100 dots. All right. For a team with the same ability to score at home and away to have a difference, well, minus away, in their means of 4.125 or greater, there is not convincing evidence that the Ravens have a greater ability to score at home. It is likely that they scored more at home in this season because of random. Okay. So yeah, if we get that small p-value, which like I said, less than or equal to 5, then you're gonna kind of be saying that we have evidence for the alternative hypothesis. So if it's greater than 5, we're gonna say we don't have evidence for the alternative hypothesis, okay? All right, and then lastly here, it says if your conclusion, or if our conclusion was an error, so if we made a mistake, and this does happen sometimes, which type of mistake did you make, okay? So I put this chart up here that we've seen before to help remind you. So it's based on our conclusion and reality. Okay, so our conclusion was obviously that we did not find evidence for the alternative hypothesis, correct? And so if we are saying, and they're saying if we were wrong, okay, then obviously we would be in this category right here. So if we didn't find convincing evidence, but it was actually true, then you can see here that that would be a type 2 error in this case. And so since we didn't find evidence, the only type of error we can make is a type 2 error. If you find evidence for the alternative, the only type of error you can make is a type 1 error. So it's important to just know the names of those two. And so what I would say here is because didn't find evidence for the alternative hypothesis, a type 2 error is possible if we obtained more evidence that proved that the Ravens had a greater ability to score at home, type 2 error. I just say something like that. So that's the key there to remember, based on which your conclusion is, if you're finding evidence for the alternative hypothesis, or like this time we did not find evidence, that determines what type of error that you could get. All right, that's it.